geobyte.
Similarly, let us take the another important problem asking like this. When a block of mass m is suspended by a long wire of length L, the length of the wire becomes L plus capital L plus small l, right? The elastic potential energy stored in the extended wire. You know, elastic potential energy, elastic potential energy stored in the wire equal to half into k into L square, where k is the wire constant, or if it is made as a spring, that k is the spring constant or wire constant. Spring constant. That spring constant equal to force per unit length. Force per unit length. Okay, look at the unit. Force is in Newton, length is in meter. That is nothing but deflection of the spring only. So anyhow, here no, the spring force equal to force per unit length. That is the deflection. Anyhow, from this force is due to weight. That force equal to mg divided by L. So in the place of k, I can write that value half into k equal to what? Mg by L into L square. It is mg L by 2. That is the elastic potential energy stored in the wire. Look at the option C. Option C is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem asking like this. Two wires are made of same material. Two materials are made same material means since Young's modulus is the material property, the Young's modulus for the material 1 equal to Young's modulus for material 2. Okay, as long as the material remaining same, the Young's modulus remains same because Young's modulus is coming under property of that particular material and have the same volume. Volume of the first one equal to volume of the second material. Okay, the first wire has cross-sectional area A and the second wire has cross-sectional area 3A. So here it is given A1 equal to A. For the second wire A2 equal to 3A. If the length of the first wire is increased by delta L on applying a force F, how much force is needed to stretch the second wire by the same amount? That means change in length for the first wire equal to change in length for the second wire. But the force acting on the first wire is F. What is the force acting on the second wire? F2. Okay. For that, let me write the general formula. As you know, the change in length of the first wire equal to change in length of the second wire. But what is the general formula for change in length? Change in length equal to F L by A into Y. A into Y. Then I can write that F1 L1 by A1 Y1 equal to F2 F2 L2 by F2 L2 by A2 Y2. Here I can cancel y1 and y2 because the y1 equal to y2. Now it can be written as f1. As you know, volume v equal to what? Area multiplied by length. From this length equal to volume by area. L1 equal to v1 by a1 and L2 equal to v2 by a2. So f1 L1 equal to what? v1 by a1, already a1 is there, a1 square equal to f2 v2 by a2 square. But here it is clearly given that v1 equal to v2, v1 equal to v2. This v1 v2 cancelled. Finally it is, finally it is, finally it can be written as f1 by a1 square equal to F2 by A2 square, A2 square, or F1 by F2 equal to A1 by A2 whole square, F1 by F2 equal to A1 is given as A1 equal to A2 equal to 3A, A by 3A whole square, A is cancelled, this A is cancelled. Finally, it is F1 by F2 equal to 1 by 3 square means 1 by 9. From this, I can write that F2 equal to 9F1. F2 equal to 9F1. That means, look at the option F. But what is F1 given? F1 is given as F. Therefore, option C is absolutely correct. That much amount of force is required for the second wire. Of course, it is written as 9 into F because F1 equal to F. Option C is absolutely correct. Understood clearly? Yes.
Geobyte.